Hello everyone, welcome to the channel. Today we are diving into the most crucial topic, that is what is feature engineering. Okay, if your feature engineering is not good, the advanced models in AI will also fail. Okay, so this is the most important part of your data analysis, whether you are working as a data analyst, data scientist, or any position where you need to do the analysis. This is the most important part and you are going to use it. Okay, so here today I am going to share with you the topics. Number one, what is feature engineering? Number two, how to implement the feature engineering using Python. Number three, different type of the feature engineering, when you should apply, when you should avoid, on what kind of the data set. So you will have the strong foundation in the feature engineering after watching this video. I will give you the very simple examples so you can implement the same like the way on your data set as well. Because I will show you how you can like first understand your features and how you can choose that right or correct type of the feature engineering to convert your data according to your model requirement. Okay, because like in my career, my every student used to ask this question: how would I know which feature is important? What method should I apply? Should I delete the feature? Should I keep the feature? So there are so many questions. So after watching this video, you will be able to find out the answer of these type of the questions. If you still have a question, we are happy, feel free to contact us. We are happy to help you. Okay, so stay with me till the end of the video. Let's start. So we will start with the definition. So what is feature engineering? Is equals to data transformation for better model performance, right? Because if you have the like the original data set, there are 50 features, 10 features, 20 features, right? It doesn't mean you are going to use all features blindly, right? There are some features which doesn't make sense to the model or doesn't make a sense to you as well. If you are working as as a data analyst or data scientist, then you may want to delete it or you may want to keep it and you want to create a new features as well according to your requirement. Here I would like to add a one more most important thing. When you are applying the feature engineering, like the types, transforming the data, if you have the domain knowledge, this is the biggest plus point for you. Okay, I'm not saying it's a mandatory, but this is the biggest plus point for you. Okay, because it will help you how you can convert the data into the like the data which is required to build a model. Okay, so now let's start. Let's move on to the next this one. So here I will give you the example. For example, if you have the data set like house sale price, you want to predict the house sale price based on the given feature. So what features do you have? I'm giving you just this example so you have the some base before we are moving ahead with the implementation using Python. That's why I'm giving you the layman example, a simple example without code. Then we will jump onto the Python. Okay. So now look at this. This is original data. You have two features and you want to predict the house sale price based on the total square like the your feet in the house and number of rooms. Okay, but you are thinking maybe this feature is not good for my model. Maybe my model will understand more. When you are going to train your model will predict more accurate values if you give the values price per square feet. So you can do the calculation here. You can divide the total price of the house with the square feet, whatever area you have. So you will get the like the price per square feet, right? So this is called like the feature engineering. You are doing some feature engineering, you are converting the original feature into the new feature. Okay, the next one is your number of rooms. It doesn't like define on which floor how many rooms. It is maybe your house, but the house you have, right, it has the like a many floor, ground floor, top floor, and second floor, third floor, right? And you want to like tell the stakeholder rooms per floor, right? and you want to, this will give you the more accurate result, or it will help your model to train, right? So this is the good example. Okay. And what you can do in this, here I will tell you. So you can convert the total number of the rooms in the house, you can convert it into rooms per floor. This will make more sense to your model, and your model will able to like build the relationship with the house sale price more accurately. Okay. So this is called feature engineering. This is the just to give you the idea about it. Now I hope you have some foundation, right? You understand the like the understood the topic what we are you are going to learn. Now we will discuss about the different type of the features. Okay. Sorry, feature engineering. We will move ahead. We will jump on to the Python example. Okay. So here you go. So this is the type of feature engineering. Okay. The first one is feature creation, as I have shown you in the slide. Okay. Now we are going to implement it using Python. So we are going to take the very simple example how you can if you want to predict the health risk based on the given age of the patient. If you are now working in the hospital, then you are the the domain expert for this kind of the data set. Okay, and this is a big plus point for you. If you are a beginner, you are from the different background, don't worry. Okay, it's okay, you can also do this, and this is very simple. I will tell you how. Okay, why you need this, why you are thinking like I should convert this column into this one. Okay, so you will understand, don't worry if you are from different background. Okay, now look at this. First of all, we will import the pandas. We are using it because I'm creating the data frame, and then we will import the package date and time. Okay, so this is the very important package, and this is the library. Okay, now here this is the data. Here we are creating a one dictionary where I have mentioned the the values. And if you are a totally beginner, you are watching the Python, like you don't have a much experience about the Python coding, then you can go back and watch my Python list. Okay, so what are the dictionaries? Then we are converting the dictionary into the data frame. Okay. Now I will show you how it look like. So we will print it. Look at this. So this is your one column DOB, and here you see there is a column which contains the patient's date of birth, because when if you are working as an administrator in the hospital, or we are going to the hospital, then they ask us to enter the date of birth, then they ask year, month, date, right? So in the database this is the actual column which is stored, but maybe your model are not interested in all these three values, right? Your model is only interested to check the age. Okay, so this is the a one thing it should strike in your mind. If you have a DOB column in your data set, then you can divide it into either three parts. You can separate the year, date, month. This is depend upon your requirement. I'm not saying it's mandatory. If you want to use all three features, then you need to convert this one column into three column. Okay, because we are not going to use as it is. Okay, this is for sure. And you mostly found these kind of the things in the time series data as well. Okay, and second thing, we are talking about you want to predict the heart disease based on the age of the patient. So I'm only interested in the one number age. I'm not interested in date, month, in these things, right? So what we will do now, so you will do the new feature creation here. So this is the way how you need to think. Okay. Now we will move ahead. Now what we will do, we will convert your this data type first into the, now we will convert your this data type into the date and time. That's why we import this package. So what is the requirement, why you need to convert it? Number one, I will show you. So I will show you the first data type. So you can use df.info, This method we use to check the data type, how many records you have, everything. Okay, so here you go. This is the DOB and this is object type. We cannot make any calculation for the string data type. Object means string data type. Okay, so here you cannot make any calculations. So whenever you have this column, you need to first check the what is the data type of DOB. Okay, sometimes it may be in the date and time, but mostly it is coming in the string data type. Okay, sorry. So now we will convert this object into the date and time. How would you do that? You would simply declare the column, this your DOB is equals to PD dot to underscore datetime DF DOB comma format in this. Okay, so you can mention the format as it is given your this one here. Okay, because this is a format, you want to convert this format into this one. So we will run this and I will show you the again df.info here. Okay, now look at this. It change your object data type into date and time, which is our requirement to do the calculations. Okay, so what kind of calculation you want to do? You want to create a one column with the age, which contains only the age number. You are only interested in the age of the patient. Okay, so you can detect, your model can train based on the age of the patient, and it can tell you what is there a heart disease or not, is there any disease risk or not. Okay, and then we will do some calculation. Here we will create the new column age. This is the way how you create the new column in the your pandas, date and time dot today dot year. So what is this? This will take the current year. Today dot year means current year. So you are going to use the method of date and time. This is inbuilt, today and year. Okay, minus df dob dot dt dot year. What does it mean? Now you have converted the object into date and time. You can use any single like the either year, month, date automatically, right? So this is the biggest advantage you have when you convert your object data type into date and time and you want to do the calculation. Okay, if you want, if your requirement is to use a month, then you can change it into month as well. Okay, so you can try at your end, you can print different values. Okay, let me know if you are doing this. And now we will check the data frame. Okay, we will run this. Now look at this. Now this command create a new column age and it is subtract it. It is working like this. So this is your current year minus 90. Okay, this is the way how this command is working at the back end. So you will get this. So this is called the most common feature engineering type, like your feature creation. And you can implement it where if you have this kind of scenario, okay, and the scenario I have shown you in the house sale price. Okay, so for this, I understand if you are a beginner from different domain, right, you need to do a lot of brainstorming, but this is the way you will learn. Okay, don't worry, by the experience when you will start implementing the projects using Python, you will understand like the features knowledge and you can use this feature. Okay, type in the comment box if you are already using this method or you are going to implement this method in your given data set. Okay, and if you need help, you can type in the comment box. We are happy to help. Okay, the next one is your feature transformation. Now we are not creating new feature, we are transforming the existing feature according to the over requirement and model requirement. When do you use this type of the feature engineering? When you see there is a lot of outlier or there is a skewness in your data set. Okay, skewness means your distribution of the data set is not normal form. Okay, there is a your distribution of the data is very like a widely distributed. Okay, high variance of the data. So I will show you what I am saying. Like look at this. So here we go, types of skewness in the data set. Okay, so we can go to the images. Look at this. This is called your data. This is whole your data. But if you look at this, like the heap, in this, you can see there is a tail, right? This is coming on the right side. This means this is a skewness. This is the like your data which is very far away from your mean. Your mean is here and the data points are here, right? So when you see during visualization this kind of problem in your any feature and you think if you like apply the feature transformation on this, then your model may give you the very good accuracy. Okay, at that time you can apply the this type of feature which I am going to share with you right now. Okay, so if you want to learn more about the skewness, you can read these articles and you will find these kind of the articles very easily. Okay, and you can also find my blog as well. Here I have the blog. Okay, you if you are a beginner you can go here. I have a data visualization many articles and you can use this one as well. Okay, now we will move back to our notebook. Here we have taken the again declare the data set using numpy array, and we are declaring the matplotlib. This is your like the library for your graphical representation, and then you are declaring your plot figure. This is deciding the size of how big like the graph you want to make. This is number of column and rows we are mentioning inside this, and then plot we are passing data set. If you want to use or you want to connect each data point with the circle, then this is you can use the circle. Color is blue, label and title. What you want to like show on the X label, Y label, you can add. This is the basic information. If you want to learn how to draw the graphs, different type of the graphs in the data visualization, then you can watch my detailed video. It's in the detail. Okay, so I have already taught in that how you can create the different type of the graphs, which graph is right for your what kind of the data set, and I have implemented it using Seaborn, Matplot, both libraries. Okay, here you will like look at this like this line chart. Okay, this is a basic line chart. Here it is showing you the frequency of the salary. If you look at this data point, okay, let me open my pen. Look at this data point uh, up to here. Okay, so this is normal. This is going in a normal case, right? Slowly, slowly going up. But if you look at here, what is happening? So this is a skewness, right? So between your 25K to 50K, there is a huge difference, right? So this point is very, very far away. Okay. So this is showing the skewness. If you see, either you can draw the line chart or either you can draw the other graphs as well, distribution graph. So you will see the more clear picture. Okay, this is also the, but mostly during the analysis we use this graph. Okay, and you will see the skewness here. Okay, now how would you solve this problem? Because now visually you can see, okay, there is a skewness in your data set because there is a huge difference between the salaries after 20K or up to the 50K, because here this is normal. Okay, but here this is going like this way. Okay, so now what we will do, you can use a log transformation method. You are not going to create a new feature. You are going to do the log transformation. You use the log transformation feature engineering method when there is a huge difference in your units. Okay, in your data set, the given feature, we have a salary feature. So this is a huge variance and data showing the skewness. So I want to adjust this one using the log transformation. It will convert your huge values into some like a readable form, and it will try to fix your skewness in the data set. So if there is a less skewness, more good model. Okay, otherwise your model will give you the inaccurate values. Okay, so here we go, how you can do that. So here you can simply say log salaries. You will declare the new variable np.log. That's why we declare the numpy library here. You will say np.log salaries. So it will normalize all your salaries. Okay. Now we will draw the graph again. Now look at the graph, right? It's a more good in the more normal form because the line seems to be more straight than this one. So there was a like the skewness, right? The line is just bending and going like this. Okay, but here it is going straight. So this is the way you can see read the graph, interpret the graph, and if you see this kind of the graphs, you can remove the like the skewness by using this log transformation method, and this is called feature transformation type of the feature engineering. And I have already explained you when you should use it, where you found the skewness, positive, negative, okay, and when you should use a new feature creation when you see those kind of the data and you want to use one of the value, or maybe the total square feet of the house, number of rooms, which is not clear, on which floor how many rooms. Okay, now we will move ahead with the next type of the feature engineering, handling categorical variable. This is also most important. In your data set, you may find the mix of the variables, integer, float, categorical, date and time, right? So here we are going to take a one example. Machine learning model does not understand the text. We all know, right? You have to convert your whole data into the numeric. So one hot encoding is a great way to do this. This is the most common method. Okay, one hot encoding. So here before in we are again creating the here your data frame, and I will print it for your knowledge. Look at this. So you have this column city. If I put this data directly into my machine, if I fit the model without converting into numeric to model on this, your model will throw the error. It is not going to train at all because machine does not understand the English command. It only can understand the numeric command. So that's why you need to transform the data into the numerical, your data set, whatever you have in the categorical form, means object data type. Okay, so now we will use the very basic method. This is the most popular method to convert your categorical data into 0 1 or numeric form. This is called pd.getDummies. This is the inbuilt method from the pandas. So this is very easy. I will show you here. So it will look like this way. Okay, so now it converted into the what format? True or false, Boolean form. Okay, 0 1. So where the city London is exist, it will say in the first column true. How it is working the one hot encoding, I'm not going to explain it here because this is a big topic. If you want to learn this, you can watch my video. Okay, I have made the one video on data preprocessing where I am explaining this in detail. Okay, you can watch that video, and if you still have a question, you can write down in the comment box. I'm happy to help. Okay, so here you have a here how many like the values in this column? 3. If you have a 4 values, then it will create the 4 columns. If you have a 10, it will create the 10 columns. And then it will make a true at which place your value is true. So first it create with the London column. So London, where the London is true? Here. Other one is a false. And so on. Okay. So this is the most important feature engineering type which you are going to use most of the time, because you are definitely going to get, it's a rare you will get all your features numerical. There will be categorical feature. Okay. This was the one way if you want to convert your categorical data or object data type into numeric. But there are also another way. This is sklearn pre-processing one hot encoder. This is recommended for the machine learning pipelines. Here you need to import from sklearn pre-processing one hot encoder library, and then you will declare the one variable instance one hot encoder. Sparse output is equals to false, means we use it to create the good matrix, because when you use this one hot encoder, it will create your lot of columns. Let's suppose you have a 20 different categories in categorical, or 20 countries. So you can assume how many columns can be there. Okay, so if you use the sparse underscore output is equals to false, it will not make your output numpy array more dense. Okay, so it is easy. And then in coded array you will fit onto the transform the city, and then you can print here your encoded value. It will look like this. Okay, but get dummies will look like this way, and your one hot encoder is this way. Okay, so here this is easy. We are just passing, this is the array we have created. Fit transform means you are fitting and transforming the data onto this numpy array. Okay, so this is the inbuilt method. This is applying two functions, transforming your numerical data into categorical data into numeric and then fit onto this array. Okay, and then you are just converting this whole into the your encoder. Okay, we are printing this. So the columns is equal to encoder dot feature gets name of the city. This is the inbuilt method, because when you transform the data using one hot encoder, if you don't use this feature, it will not show you any column name. It will show you just the column 1, column 2, column 3. Okay, so if you want the column name and you want to know like which value belongs to which column, then you can use this feature. If you want to do try to end without using this one, you can. Okay, and let me know if you tried it and show me the result. Okay, so these were the like your different type of the feature engineerings. This is the optional tips. Okay, and this is I have mentioned the another like one hot encoder methods, but the most common is get dummies, one hot encoder, or sometimes you use the two categorical as well, but you are most of the time you are going to use this one. But I have mentioned the pros and cons in this notebook. Okay, and you can check it from here. Okay, now we will move to the next method. This is feature selection, removing unimportant feature. This is very interesting. If a feature is not like you think it's not useful, you can delete it. But big decision is how would you decide I'm going to delete this feature? We are afraid from it because you are losing the data, right? Later on, maybe you regret on this. I deleted this data. Maybe it has a like a give a more contribution to my model. So this is a big decision. Take this decision wisely, be calm, okay, and keep patience and then take this decision. Okay, but I will show you the example and make the decision for you, how you can take the decision easily. Okay, I will make it very easy for you. So here we will import the pandas. We will create the three features, height, weight, and this. Now check the correlation. So before deleting any feature, you should check the correlation. Correlation is the inbuilt method for of the pandas, where it will show you the how the each feature related to the target and how they are correlated with each other. If your independent features are correlated with each other, this is not a good sign for your model. Your model cannot be perfect. Why? Because if you are going to delete one feature, other will is going to affect very badly. Okay, so we need to check out these kind of the things. Okay, now here we will run this. So look at this. This is the like the numerical output, but I will show you in the picture. So here we go. We will take it on the upside. This is called heat map. On the right side, lighter the color, less the strong relationship. Darker the color, good relationship. Hard relationship, strongly correlated with the target. Okay, there is a no target, we are just checking it, right? So here we can assume BM your and like these three features. Okay, so now look at this, how you will read it. First of all, look at height and weight. Okay, so you can look at the height and the weight one. Okay, the height and weight is in between, strongly correlated with each other, right? But if you check the weight relationship with your BMI, this is your BMI, this is the BMI, how it is related to this one, 99%. And BMI is also correlated with your height as well. Okay, so this means although this feature is strongly correlated with your the rest of the two features, but this is not going to be beneficial for you. Why? Because it is not contributing the BMI in the height and weight. Okay, because BMI is decided based on the height and weight, not the height and weight is decided based on your BMI. Okay, this is the body mass, right? So what is your height and what is your weight, then we calculate your BMI, right? So this is that's why you can delete this feature. This is not going to contribute in your like the model training, right? if you are giving the height and weight to your model and you want to detect the heart disease, let's suppose you are sharing the height, weight, or maybe you want to check the your BMI, or you want to check something else, you want to predict it, then you can use these two features, right? And thinking it as a layman as well, if you're a domain expert you will also understand, but I'm also looking at the heat map as well. Heat map correlation method is your best friend when you want to decide to delete a feature. If you think feature has a like strongly correlated with every other feature, right? Except target, okay? Not target. So if this is highly correlated with your other features and they are correlated with each other as well more than like the time, one time, then you can delete that feature. Okay, but this decision you need to take very very wisely. Think as a layman, think if you have a domain knowledge, and then take a decision to delete this. Okay, and then you can fit onto the model. If your model is not giving you the accuracy good, then you can go back to your original data set and then you can try with that feature as well. So this is just the experimental things. Okay, and now we will drop this column, and here you go. This is the one. Okay, so you are left with this one, and now you can use these two features. Okay, so in this case, what was this? More features don't always mean better performance. If features are highly correlated or irrelevant, they can hurt the model, as I told you, right? Because BMI is not something which can help your model, right? If you have a height and weight, then your model will learn from it, right? Because BMI is a combination of these two features. Okay, so this is the way how you need to think. Okay, so take this decision wisely. So these were the all top math feature engineering types. I hope it make you like sense. And if you have any question, free feel to type in the comment box. And I am also curious to know which method you are going to use in your data set and why. How did you take that decision? Are you going to use feature creation? Are you going to use transformation? Are you going to use the deletion method? Or are you going to add the new feature? Okay, so just let me know. This is the pros and cons I have mentioned here. So now if you have any question, just let me know. Okay, and thank you so much for watching this video. Okay, and if you are new to my channel, please subscribe my channel. See you in the next video. Happy AI coding. And over science data science goal is to help you to achieve your goal. Okay, so you can contact us by writing your problems in the comment box. Okay, thank you so much for giving the time to watch my video. See you in the next video. Happy AI learning.